So I will begin now then. So Ian, as the one who proposed inviting you to speak to Lunch and Learn, I'm really pleased to welcome you. And I have occasionally dined at Chez Piggy, so I may well have been the unknowing beneficiary of your work there as executive chef. Certainly, as a Kingston citizen, I deeply appreciate your service to our community as our member of the Provincial Parliament in the previous term, and as critic for environment and sustainability, among other roles you played there. You carried to the Legislative Assembly many of the concerns shared by those present today, and certainly reported clearly and regularly to your constituents. So thank you for that great service. And you have a close connection with your successor, MLA Ted Hsu. Oh, Liberal, you were NDP, it doesn't matter. You share the same concerns, I think, many of them. And you had in common your leadership in the organization Switch, a sustainable energy community organization. And I happened to hear your talk that you gave to Switch, and inspired by that, I said, I really hope that you'd agree to talk to us as well about the current chapter in your life. And to all present, Ian has deep roots in Kingston, although we learned that he's a Newfeet boy. He was born in Cornerbrook, but he attended, was it LCVI or you said Sydenham? Sydenham, okay.
Yeah.
And then went off to Trent for international development, political studies. He worked with the Canadian High Commission in Accra, Ghana for a bit. Then he did a master's here at Queen's in public administration. Sometime in his career, he worked in Iceland, but again, he's chosen Kingston as home. So he's been chef, MLA. He was on the Kingston Frontenac Lennox and Addington Food Policy Council. And now, as an entrepreneur, still he finds time for reading, camping, and, well, he hopes to get back to hockey soon. Food security and housing figure highly among social concerns addressed in our series. And when you spoke to Switch last year, you had just begun your new business of 3D printing of buildings, some social housing included in that. And you told us that when your work in Ontario had to stop because of low temperatures, you'd pack up all your gear in 2 semis and drive them out to BC where it's warmer and continue. So I thought it would be great to wait until some of that work had gotten underway, and then you could speak to us now, and we could have an update on that as well.
Sure.
So over to you. We'll as you know, we close at 2, but we hope to have some time for questions and comment. I'm sure there'll be lively discussion. So Ian, welcome, and we look forward to your talk.
Yeah, thanks everyone for having me. It's a pleasure to be here, and when you hear it all summarized, I feel like the careers I've had are rather eclectic, but it's been a lot of fun, so we'll keep it rolling. I'm going to share my screen here with everyone, and I'm going to walk through a presentation and then also move over and show a few videos to kind of show we've got a lot more under our belts now in comparison to when I gave the last presentation. So some of this is going to be a bit repetitive, but I hope that we also show you some new stuff. So Nidus 3D was founded about 2.5 years ago, around the time that I decided I really didn't want to run again. That it was a fantastic experience being an MPP, but that I was ready for something a little bit, I guess, quieter, and certainly something more local in Kingston. And I was pretty keen to move back here and not have to live in 2 places at once. So Nidus 3D, we're a 3D construction printing company. We have a large-scale gantry-style printer, which you can see in the background there. That's our key operator, Chris, and one of the leads from the company that produces the printers. We've partnered with a company in Denmark called Cobot, and it's a huge sort of gantry-style box printer. Imagine like a small 3D printer. I think many of us have probably seen some pictures and videos of small printers, and just scale it up to a massive size, and we print with concrete instead of plastic. So I'll go through this a little bit. We founded it in 2021, partnering with Cobot International, who are one of the world leaders in the development of these large pieces of machinery. We went through our first build season, put up 3 structures and did 1 art project that's down by the water in Kingston, a water snake project just down by the delta along the water. It's meant to look like a water snake coming in and out, and I'll show you some photos of that later. And the other work that we did was what we called a series of escalating proof of concept builds. So we started with a single story slab on grade building, moved to a multi-story slab on grade building, and then moved to a basement +2, which is just being closed in on the corner of Adelaide and Division now. These represented multiple North American and world firsts. It was the first 3D printed basement in the world. First multi-story concrete printed building in the world, and a couple other little feathers in our cap that we like. Where we are right now is we're expanding capacity. So our second printer just landed in the port of Montreal, and it's going to be here in a couple of weeks. And we're going to be using it to actually print our own headquarters out on Battersea Road at the corner of Frontenac and Battersea. We've got a property out there, and when we do it, when it's completed, I believe it won't quite be the largest 3D printed structure in the world, but it'll be the second largest. So, and certainly the largest in North America, which is kind of exciting to get to do. A little bit about the technology and what we do. We lower costs and decrease friction. We do this in a number of ways, and one of the key ones is that the printer, it's a digitization of construction in a lot of ways, and so it's a very much a data-driven approach to putting up a building. And we think about construction less in nails and 2x4s and time and labor, and more about in data points like layer time, layer height, how tight the corners are, and the speed of the print head. And we're able to very, very accurately predict exactly how long it's going to take to put up a building. And it's fast. We're at about half a story a day right now. I think we will get to a place where we're printing a story of a building a day in the future, and we're getting fairly close to that. We're competitive right now with other masonry forms of construction. So ICF, insulated concrete forms, which are the 2 pieces of insulation on the outside, and then you pour concrete down the center. We're exactly basically the perfect inverse of that. We do two veneers of concrete, and then we pour the insulation down in the cavity in the center. We're approaching cost competitiveness with wood frame. Wood frame houses are still slightly more affordable than what we do, although we feel quite strongly that the product we're delivering is superior to a wood frame house. So it's a masonry product. It's made out of concrete. These homes hopefully will be here well over 100 years. They're climate resilient. It's affordable to insulate them to extremely high performance standards. Our first house in Leamington is net zero ready and actually meets passive house standards in terms of its performance. And again, we're doing this with a level of predictability that is hard to compete with. OBC is Ontario Building Code, so all of our buildings have been permitted. We had the first residentially permitted 3D printed structure in Canada, and all of the other 2 buildings we put up, and the future ones we've successfully managed to get them permitted within the existing Ontario Building Code as either special accommodation structures, Part 9 structures, or Part 4 structures, masonry built structures. And there's a few ways we kind of add a bit of extra engineering into all our builds to make sure that there's no questions about the long-term strength and performance of these buildings. This is the founding group. So myself, Hugh Roberts is the builder of the group. He's done a number of gentle densification infill projects, in Kingston, came from a background of lean manufacturing and very much has brought that lens to bear on what we do here. And then Ted Urbanchik came on board. He was a founding member of the founder of ESG Solutions, which was a Kingston-based company.
Ian, are you changing slides, by the way?
I am. Is it not changing for you?
No, it didn't change.
Uh-oh.
We just, yeah, there we go. Now it's going.
What about now?
Now, yep.
I'm so sorry. All right, there we go.
Yeah.
Okay, this is what you missed. So that was just a walkthrough of our timeline. This is what I just went through, and then the members. So Ted founded a company out of Kingston called ESG Solutions. Their specialty was seismic sensors for human-caused micro-earthquakes. So they worked with the mining industry to prevent accidents and environmental concerns around mining. And he's come on board as a kind of growth advisor. I believe we're his fourth or fifth startup, founding member of Round 13 Capital in Toronto, which was a group that tries to keep Canadian companies Canadian while they scale. There's a kind of threshold we hit in Canada if you have a growing Canadian company where it becomes very hard to raise the money to scale to the next level. And so when companies hit a particular valuation, the sort of uniform experience is that they either have to sell to an American company or either sell the company or pursue sort of American venture capital and again, losing control of the Canadian aspect of the company. So he was part of the group that created this. I believe they now distribute a little over $2 billion a year in funding. And he's stepped away from that and come on board to help us grow, which is fantastic. So a little bit about why we started Nidus and where we are in this. So the building, I'm sure all of you have seen the headlines about the housing crisis that we have, which has been around for a long time. A lot of the reasons I was interested in the sector came out of work I was doing as an MPP on housing affordability and the housing crisis in Ontario. And I started looking for things that I thought would be viable solutions to help begin move the needle on that affordability crisis that we have and availability at all. And there's a lot of sort of policy levers that you can pull that will nudge stuff in the right direction. But fundamentally, none of the changes that were being proposed at a provincial level or at a federal level were going to dramatically change the problem that we were facing with housing. We have a dramatic lack of labor, and our best case scenarios for training of youth skilled labor imply huge shortfalls in terms of the availability of skilled labor, particularly as the baby boomer generation begins retiring. Currently, we're on track to be retiring 2 people out of the skilled trade sector for every 1 we're training. And we already have a labor shortfall. We have incredibly volatile material costs that dramatically change the sort of underlying viability of construction projects. The huge increases in the price of lumber that we experienced a couple of years ago, all sorts of other ones, supply chain problems. Now that's being pushed more by inflation, and we're seeing a very uniform rise in everything. But again, it's making affordable housing construction all the more difficult to do. And the last one, I think, is extremely important, and that's that we put up buildings with an impossible number of steps. We have created a level of process complexity related to building that is very difficult to execute and cost prohibitive. And so what I mean by that is we build homes with hundreds of different types of materials, thousands of different types of components, and tens of thousands of different steps to get a building out of the ground. And all of them involve different trades and different people coming and going that you have to schedule. And anytime you have that level of complexity and that level of interaction between different types of building material, or we usually refer to this process by the SKUs, looking at it in a lean manufacturing way of trying to limit the amount of SKUs that we're putting into a building, it skyrockets cost. We've had tremendous material increases or improvements over the years, and gypsum in the 50s was transformative and moving away from plaster. Spray foam insulation has been a huge step forward in terms of building envelopes and the sealing of them and having energy performance. And I mentioned earlier ICF, the insulated construction foam form blocks. Again, a huge advance, but ultimately ICF is a bigger brick. It was still needed to be stacked by people and tied together, and it still is an extremely labor-intensive and long process to get ICF buildings out of the ground. And 3D construction printing, I think, represents for the first time a change in the process of building. It's the first technology that I found that I thought began to address this process problem, in that it's automating a portion of construction. And so we're simplifying the structure. We're limiting the number of different materials that are going into that structure. The printed concrete can take the place of the exterior vapor barrier, the structural components. You can smooth the walls enough that there's no cladding required on the exterior. You can do a spray and plaster on the interior and eliminate the need to put up drywall. And so it begins touching a lot of the different scopes of work involved with construction. And by simplifying that, I think it has a real chance at beginning to lower the cost of construction in a really significant way. This is just a bit of a reiteration of all of those things that I'm talking about. So we want to build 400,000 homes a year over the next 10 years, 4 million new homes in Canada, and Ontario, that's 1.5 million new homes. And honestly, we have absolutely no viable path for getting there right now. I think we might. I think we have enough time that if we work very, very hard on it, we're going to be able to hit these goals. But if we just maintain the status quo, there's no real viable way to do this. So this is a little bit about the printer and that we use and why we're using it. You can see it there on the left, set up. That was the original one, set up inside for some testing. On the right is a series of pictures from the early builds that Cobot, our partners, did. You can see it being loaded into 2 shipping containers. That's one of the 2 shipping containers that fits in there. The middle picture is the first multi-story 3D printed house in the world. It was done by Perry Group, which is a large construction and concrete form company based out of Germany. And then on the right is a schoolhouse that was printed in, I believe that one is Angola. A couple of the things that I'll touch on there in terms of some of it's pretty self-explanatory. Second gen printer, so it's the only 3D construction printer in the world that has moved beyond prototyping phase and into a deployable, purchasable unit. It's been deployed in almost every continent in the world now, I think, except Antarctica. So that's very exciting that it has a global footprint. It's modular, so we can change the size of our printer. The first printer we bought can print a building that's 40 by 40 and 3 stories tall. Our next printer is extending the length of our printable area up to 62 feet. So we're getting bigger and bigger buildings. The tangential control is really interesting. That means that there's a U-axis rotation on the print head, which means that instead of sort of the lumpy stacked noodle look, you can actually smooth the walls as you go, which again will eliminate a whole other scope of work from the build process. They're, I think, leading in terms of development. They've got very exciting additional attachments coming that they can add on to their printer. And the last one there is one of those developments, the XL printer, which was a partnership with General Electric to print windmill bases. And that is going to have a printable area of 80 feet by 80 feet by 7 stories tall. So we'll be in the realm of printing mid-rise apartment buildings when that's released. I touched a little bit on the Ontario Building Code. We're actually helping, our lead engineer sits on the board for the ASTM ISO committee that is developing the global 3D printing standards. He's one of the co-chairs of that board down in Boston. So he disappears for a week every couple of months to do that. Those standards are about to be released, and there are what is going to form the basis for national and provincial building code adaptations for 3D construction printing, which is very exciting. Right now, there's a bit of a higher threshold in terms of getting our buildings permitted. Nothing unmanageable, and our experience has been talk to the municipality as early as we can, explain what we're trying to do, and then put them in touch with all the engineers that tell them how we're able to do this. Not my forte, but I hire very good engineers. So we've been extremely lucky in the partners that we have gone to work with. That group up above is the team from Habitat Windsor, Essex, who we built the first building with, and a number of other partners that have been fantastic down below, University of Windsor, Queens. The banks have been really really fantastic. This has been on the radar of the banks as an area for investment. And so even though we're a startup, we've actually been able to access a lot of institutional support for getting this company off the ground. So this is a little bit about where we started. I mentioned a few of these. The one on the left is the Leamington project. 4 units in a single story. It's for youth in recovery. It's on the site of a youth center built by Habitat, partnership between Habitat for Humanity, University of Windsor, and CMHC's pilot project. It was partially funded by CMHC. The second one on the right is just being finished now. It's a studio. I'm going to show a video of both of these at the end of the presentation that tells you a little bit more about it. So the ground floor on that is going to be a workshop. It's a local business owner who wanted a CNC workshop beside his home. And then the second story, which we just started printing up there, is going to be a little 2-bedroom apartment that's going to actually attach to his house. These are the more recent ones. The left is the first 3-story structure. We printed it. That includes a basement. We got up the first building on the corner of, as I said, Division and Adelaide Streets. It's just being closed in now. This one's interesting. We're actually only printing one of the 2 buildings, and the other, the developers wanted to use another new building technology on the other one and do a comparative study between the 2. So we're very excited to see the results of that when they get the second building up. And then the one on the right is the water snake project that we did in partnership with Raw Design and the city of Kingston. And it's meant to look like the sort of skeleton of a water snake coming in and out of the water down by the delta, like I said. And what's very cool about that, which we were really excited to get to do it, is that every single one of those pieces is unique. And if you had wanted to do this with another technology, it would have been incredibly prohibitively expensive to build all these unique pieces. You couldn't have done them in concrete. You would have needed a form for every single one of these pieces. And even if you were to do them in wood, you would have needed different templates and a lot of manual labor to do this. And we were able to actually print, you can see them on the bottom right there. We're able to print both of these in two goes around. So each 2 days of printing, we created all of these pieces. We had to give a few days to cure before we could lift and move them, but we were able to do all of these within 2 days. This is a little bit looking towards what we're working on next. We're scaling the size of the developments that we're doing. So we're moving into multi-unit apartment buildings, small subdivisions, and our own commercial structure, which includes a warehouse and an office. But we're also continuing to try and improve the other parts of the build process. So what that refers to, there's a couple of things. Again, we're trying to look at the process complexity of putting up a new house and trying to limit it. So we're working right there on the left on an opening treatment, which is going to be a compression-based window installation system. We're just in the process of testing the first prototype of that has been built. Again, 60%, as it says there, of the total cost of putting in a door or window is actually the labor associated with it. So the key here, the components going into it will cost about the same as a regular window, but we'll be able to dramatically reduce the labor and accelerate the speed of construction with this. We are keenly aware that concrete is a very impactful material for the environment. It creates a lot of emissions globally. And so we're working with a number of groups to look at ways that we can reduce, in particular, the embodied carbon that is in concrete. The delivery of the material we use is extremely efficient. So compared to other concrete buildings, we use a lot less material. We mix on site, so we're keeping trucks off the road. So we've got some modest improvements there in terms of other concrete and masonry structures, but we still have a long way to go. And the key to kind of changing that impact on the environment from a building perspective is going to be changing the process of how you make Portland. It's an extremely carbon intensive process. But there are some ways where we can use different admixtures. We've just partnered with a company out of Florida to start introducing a graphene-based admixture into the concrete, which would allow us to reduce the volume of concrete by about 25% while maintaining exactly the same strength characteristics. And there's a couple other things that we can do in terms of lowering the embodied carbon in the Portland itself. That's a problem being faced by the entire industry, and I think that we're going to see some huge improvements as carbon taxes, in whatever form they take, start to accelerate in Europe and in parts of the States and parts of Canada. I think you're going to see that this industry in particular is going to have a huge need to alter how they produce this. And so I think there's some stuff we can do as a little startup in Kingston, but I think that we're going to start seeing the larger industry players really start to be able to deliver a lot more options in the form of low carbon cement. The last one is, I think, a kind of exciting project, and it's the development of a batching and pumping system built from the ground up for 3D construction printing. All of the groups in the world right now are building these printers. I like to say that they're robot people. They have not particularly paid attention to the mixing and batching and pumping side of things. They tend to pair their fantastic futuristic automated construction tools with off-the-shelf technology that was really not developed for this application. In particular, around the pumping side of it, anytime the previous demand on concrete pumps has been more faster. And so you want to up the pressure, you do it so that you can deliver a higher volume of concrete to the end product. And what we actually need in concrete printing is a very low volume at very high pressure. And that's a unique requirement that no one's really built a pump to do that. So we're working on that. And then on the mixing side of things, we mix everything on site. We get deliveries of sand, aggregate in Portland, and we make the cement ourselves or the concrete ourselves on site. The batching systems that are out there just aren't accurate enough in terms of their mixing and the level of accuracy we need, particularly around moisture content. And so the dosing of the liquid can fluctuate 5 to 10%. And we really need to be operating with moisture variables around 1 to 2%. So we've partnered with a couple of groups to try and solve this problem. And we should have prototypes of both of their solutions to the batching this summer coming online. So it's cool. I think we're doing some pretty exciting stuff right now with the technology. I'm extremely excited for where we're going to be able to take it in the future. I think we're going to see tremendous steps forward. This is a couple of the projects we have coming up. Like I said, there's the one on the left is a series of 3 units. So you have 2 1-bedrooms on the ground floor, and then a 2.5-bedroom unit on the second floor. And then on the right, or the middle one there, is two 9-unit buildings. We didn't design those. They look quite Soviet. I would have added some more windows and a little more natural light, I think, than the developer tried to, but he's very focused on the affordability side and accessibility side of this. So very excited to get to do that. And then the last one on the right is actually the headquarters that we're printing. It's just kind of the outline. And how we're able to build a structure that big is actually 2 printing positions. So we print the warehouse side of it, and then we move the printer over and we print the office and storage side of it, and then we're going to join those 2 together and end up with a really significant structure. I don't think this video is going to play in here because I tried to do it sooner, so I'm going to switch to another window, play a couple of videos, which won't take too long, and then I think we can answer some questions. So the first one is the first video that we did. I'm just going to play it in this window. I'm afraid if I make it full screen, it's not really going to work. So we're just going to try it here. Can you see? Is it playing? Okay.
In the early days, I was hesitant because my mission is to deliver safe, decent, affordable housing. And at first, I wasn't sure how 3D printing could actually be achieved safe, decent, and affordably. So there's not a lot of companies doing this in Canada, so finding Nidus 3D was a blessing. When you're doing innovation, when you're rising to a challenge like housing, when you're rising to the challenge of the environment, you have to be bold and you have to be able to pivot and come up with ideas and solutions. Just the minds behind Nidus are all about ideas and solutions, and then the motivation is we're going to succeed no matter what.
So I actually just got the final, it didn't arrive in the summer, the final video from the group that did this. So there'll be a longer one to show folks in the near future. The other one is, so they finished this project in the summer and or in the fall. And so I'm just going to play this and show you all a bit about, I wonder if I can make this a little bit bigger if it's going to, yeah, there we go. So you'll have to listen to me talk on this one a little bit more and then I'll be able to answer a few questions.
Hi everyone, we are back in Leamington, Ontario at the site of the first residentially permitted 3D printed structure in all of Canada. When we left here in early June, it was just walls. It was the first 3D printed structure. It was Nidus 3D's first project ever. And over the summer, they have done this incredible job at finishing it. You can see the roof and windows and everything there. And in a little while, we're going to take you inside and do the big unveil of this Canadian and North American first. But right now, we're headed over to the Bridge Youth Resource Center where they're going to give a presentation and tell us a little bit about the journey that it took to get this building out of the ground.
These are the first 3D printed homes for residential use in Canada.
This project is benefited from innovative partnerships and innovative construction methods that will help us find more efficient, scalable and sustainable ways of providing housing for those who need it most.
More than investment by all levels of government, we will need partnership to solve this crisis. And more than investment and partnership, we will require creative thinking and innovation.
Oh my gosh. So all of the furniture has been donated by Peppermint. So keep it. Yes! Like even the texture on the wall, yeah, it looks fantastic. We came up to Kingston to see your team in action. Yeah. And that was the day I knew that we could do this. That was the day that I was like, this is going to work.
We were thrilled to be part of this, and your phone call changed the direction of our company. So we're incredibly thankful for that opportunity, but it's everyone else as well who collectively pushed this forward, which is how we're here.
So we wrapped up here in the spring, and there's a whole bunch of folks who stepped in and did incredible work to turn our printed structure into a finished house ready for people to move in. One of those folks is Bruno. He's with the University of Windsor. He's been instrumental in this process. So Bruno, why don't you tell us a little bit about everything that's been done since we left?
The finishing work here took a lot of attention to detail and thinking through this different technology, but in the end, everybody that sees it will see that it's worth for sure.
You're figuring out how to do stuff interacting with 3D printed material that's never been done before. This is the first one in Canada.
We had to attach some tack-ons all the way across the baseboards and then come with the stained pine and give this nice rustic touch to it.
So Marcos was one of the students who was working with the University of Windsor on demonstrating the strength and the viability of printed concrete to perform in Canada and Canadian climates. And Marcos, you want to tell us a little bit about the work you did to get this off the ground?
This project is to get results from structural, behavior, thermal capacity, water penetration capacity of those elements done by this technology.
We met Marcos on this project, and I'm so thrilled to tell everyone that Marcos is coming on board with Nidus 3D. He's moving to Kingston, I think this week.
Yeah.
very, very soon. So the truck is packed, he's ready, and he's going to come on board and head our engineering department so that the lessons that we learned on this project can be applied to all of the future Nidus 3D projects going ahead.
Super excited.
I think we better go inside and take a look.
All right, here you go.
Oh my God. Bruno, this looks incredible. Like, look at this, look at the trim. That's stunning.
As you see, the kitchen, the living room. I wouldn't even say it's a tiny home. It's more like a one-bedroom apartment.
Yeah. You've knocked off a lot of the kind of burrs, so it's not going to hold a lot of dust. It's going to be a lot easier to clean. Man, I think it's fantastic what you've done with this.
This building is supposed to be net zero ready, so we have this feature of being as airtight as possible, waterproof. It's everything that you would want the building to be. Instead of the common spray foam, what we used was pour-in-place foam, which is a little bit more of a liquid solution. Expands with the time, and then you go and pass the same way as you go with the printer.
Let's take a little peek at the bedroom, a full double bed in here. And again, we have that beautiful printed texture all around us.
Over here we have this rounded corner that was 3D printed as well.
So 3D printed on a polymer printer?
Yeah, wood filament actually.
With wood filament,
Yes,
so they're
I
actually wood maintaining it all the way around?
Yeah, it's it can be stained, it can be painted.
I'm so impressed. It's just, I'm blown away, Bruno. So yeah, lastly, let's take a little peek at the bathroom. And one of the really cool things about the design was the concentration of the electrical and the mechanical. The kitchens and the bathrooms are all concentrated at the center of this building, which makes it more cost effective to provide all of those services to 4 units than it would if we were doing them in kind of 4 separate places.
That's right. We're going to install grab bars here, and this is going to be universally accessible.
All right, folks, that's the tour. I can't stress enough how excited I am to be here and how blown away I am by this structure and everything that they have done. When we left this place, it was a construction zone. We had a huge printer up still. There was concrete everywhere. There was backhoes. And to come back and see it like this, it's frankly inspiring. And it's exactly why we're doing what we are trying to do at Nidus and pushing the boundaries of technology and construction. The beauty that surrounds us is incredible, but it's also extremely functional. They fit so much in a small space. It's net zero ready. It's going to be an extremely efficient and green place for people to live. And it's a first in so many ways. It's a North American first. It's the first residentially permitted 3D printed structure in Canada. And we at Nidus are just so thrilled that we got to play a small role in bringing this building out of the ground and making it something that is as livable and functional as it is. It is a first in a lot of ways, but I know it is absolutely not going to be the last. When you see the success of a building like this, we know that this technology has such incredible promise. This was only chapter 1 in the Nidus journey of trying to bring 3D construction printing to Canada. We're working on so many other incredible projects, and I hope that you follow us along on all of them. Make sure you check us out on all our social platforms. Our handle is @Nidus3D, and we've got a lot of cool stuff to show you. Thanks so much, and I can't wait to see you again on the next build. Let's relax for a bit.
Yeah. Put some property routers in there.
Yeah, exactly. I could live here.
And that's the videos. So I'm going to stop sharing now. 5 minutes over, but I think that's okay. And let's answer some questions, if I can, if people have them or not. Oh, I think you're still muted, Bill.
Just unmute and to speak up. James, you had your hand up, I see, and turn your video back on. And
yeah, just from a practical point of view, Ian, first of all, I'm very impressed with the innovation and the ideas behind this. But in a practical point of view, how do you run the electrical conduit?
There's 2 ways. So the Leamington project used a combination of both. Part of it was run in the wall cavity before the insulation was poured in. The printer is accurate enough that you can build into the BIM file, the building information model file, where the electrical outlets need to be, and it will interrupt itself and allow you to place those as it prints. So that's one way of doing it. And then behind that, we put the conduit, and then we fish the wires or push the wires through the conduit and into each of the boxes. The other part of it was in the bathroom, they use surface mounted electrical. So a little bit more of a rustic look in the bathroom. They tried to do a couple of different approaches for the electrical and all the MEP, the mechanical, electrical, and plumbing. I think there's going to be a need in the other buildings we're doing where, particularly on heavy plumbing walls, to build a false wall in front of the concrete and just run it in the traditional way and then drywall that. I think that's actually going to be a little faster and more affordable than trying to push the plumbing through a lot of the printed material.
Good, thanks.
Juliet, unmute.
Right. Yeah. Hi, Ian. This is so impressive, and it's inspirational to see people thinking really out of the box. It's wonderful. My question was always going to be about the concrete, and I think you answered it in part, saying that, you know, this is obviously a problem everyone's going to have to deal with around the carbon footprint of concrete.
Yeah.
And it went by fast, and I wasn't quite sure. You're saying that there are ways, I mean, maybe using less concrete, but ways of improving the carbon footprint of the concrete itself, of the Portland itself. Can you say, without getting into sort of the chemistry, can you say a little more about that?
For sure. So, yeah, there's like I said, there's some stuff that's being worked on by other folks. There's a company in the U.S. I think it's backed by Bill Gates. You need part of the most of the emissions that come from the creation of Portland cement are the byproduct of two processes. One is the off-gassing from heating some of the components that go into it, the lime in particular. And the other one has to do with the fact that you need to get the material up to about 1600 degrees in order to make it. And so the group in the US has solved part of the heating problem by using concentrated solar, and they can get it up to about 1200 degrees with concentrated solar, and then they're only using natural gas to do the last bit of the heating, which again lowers emissions associated with that production. So that's one of them. That's one company that's not market available yet. That is a prototype approach to the creation, but part of the groups that are, I think, working in that direction. Some of the stuff that's more accessible for us is the mix that we have is extremely strong. We're hitting an MPA of 45, 48 after 28 days, which almost meets the threshold for infrastructure concrete. So, and was well beyond what you need for residential, massively over what you need for residential. So we can reduce it a little bit by substituting some of the Portland with other admixtures. You can do crushed limestone dust. And it does lower the strength a little bit in terms of the performance of our concrete, but we've got so much room there, we can start replacing part of it. We're also looking at, there's a lot of data and research on it, so it's a very common material, looking at introducing recycled glass aggregates. And so crushed glass as a replacement, again, for some of the Portland that would lower it. The other one that I think is really interesting, which we kind of lucked into because of our location and proximity, is there's a mineral called wollastonite, and there's a wollastonite mine out on Highway 15. And if you take crushed wollastonite, you can replace lime in the firing process, and there's a dramatic reduction in the amount of off-gassing that happens in the firing process. So if we were to take the concentrated solar solution and pair it with the wollastonite solution, we'd be talking about some very dramatic reductions in terms of the carbon emissions associated with production. The wollastonite's very interesting. It's actually a carbon absorbing mineral. So if we were to also use it as an aggregate in the building, the exposed wollastonite would over its lifespan pull carbon in from the atmosphere in a small way, not in a way that I think meaningfully would really offset the footprint of the home. But it's interesting to explore that. There's some really interesting research coming out of China around carbon absorbing materials that you can introduce, because that's actually, you know, it's kind of like everyone, you know, they finally discovered why Roman concrete was so strong and got stronger over time, particularly when it was exposed to salt water. In a very similar way, they're trying to do the same thing, where you actually strengthen the concrete over time by having it absorb atmospheric carbon as it sits there. None of those are there yet. I think about this a lot. I mean, as you said in the intro, I was the environment critic, and I care about emissions a lot. And I think it's hard. We have a desperate need for housing. I think this is a transformative technology. And, you know, I do hope the buildings are here for hundreds of years. I think that helps. A lot of the wood frame buildings would need to be torn down and put back up, and then, you know, perhaps less initial embodied carbon, but maybe not over the lifespan of the building. The last thing I think is going to happen, which I'll touch on quickly, this is a very long answer to your question, and I did go directly into the weeds, which is where I like to hang out, I don't think concrete will be the only extrudable material in the future, and it already actually isn't. There's going down to visit them. There's a group at the University of Maine who created a wood fiber 3D printed building, so a larger version of the same wood filament printer stuff that was used. I'm not quite sure. I really want to know how they did it, because most of them rely on epoxy resin, and you can't. That's UV susceptible, and so you can't use an epoxy resin on a, like, you'd have to have it fully covered up and ensure that it was never going to be degraded by the sun somehow. So I'm not sure how they did it, but we're going to go down and spend some time with them. I'm interviewing them for another little feature that we're doing. So I think that's going to be cool.
Bruce.
Don has the question in the chat.
Oh, Don, okay. Oh, yes. Donna, to everyone, could you explain how the multi-story building work in terms of their structural integrity? Is steel incorporated?
Yes, it is. So we have horizontal or lateral reinforcement's pretty straightforward. We have a reinforcement schedule that we put in. It's C-bent rebar that you embed into a couple of layers, and it ties the two veneers together. That's very straightforward in terms of the lateral load strength of the building. Compressive strength is done not relying on the printed material. So this is one of the ways we were able to get the buildings up in Canada under the building code, is that we add in a lot of probably redundant but still necessary traditional engineered structural elements. And by that I mean traditionally poured and reinforced columns. And so there, you saw in the video, there's a few round bump outs from the wall. And those were hiding, we actually 3D printed formwork, so circles, and we're able to drop a traditional rebar schedule down them and then pour traditional columns. So the roof structure is actually resting on that. Like I said earlier, the concrete is extremely strong. We know that it could carry the load of the floor without any issues, but until we have those international standards released and until the building code is updated in Ontario, I suspect we're going to be incorporating these sort of secondary engineered features for the foreseeable future. They don't add a lot of cost. Because we can print the formwork itself to hold the whole thing together, they don't add a huge amount of cost to what we're doing.
Great. I have two questions, but I just want to see if anybody else has any questions.
Eleanor has her
comments. Eleanor, please.
Thank you. I'm in a house coat because I washed my hair before this. You don't need to. Well, here I am. I don't know whether I'm supposed to know this already or not, but is the idea that one of these 4-unit places would be bought by a city and then given out to 4 homeless people that we see on the street, or that similar homes would be built with a couple of bedrooms for, say, single mothers who would buy them, or how is all this supposed to work?
That is really up to the folks who hire us. So we're looking to work on I think projects that have a social lean. That's part of the mission and vision and values of Nidus 3D. We are a construction service company, and so we are not developers ourselves. We don't buy the land. Frankly, we're not capitalized enough to buy the land, even if we wanted to. So we work with developers and to try and get them up. We are expanding our partnership with Habitat for Humanity and looking to do projects with them all across Canada, and look at working with any other groups. But really, it comes down to what there's sort of funding and money in place to do. So really, we arrive and we put up a printed structure. I think we'll get to a place where the efficiencies of our technology dramatically lower the total build cost for municipalities or organizations like Habitat, and we'll be able to deliver quite a bit of very affordable and attainable housing.
For example, what would be the cost of that 4-unit building?
That one in Leamington was a pilot project. So I think if we were to do it now, those 4 units would be, I think, probably about $440,000, $450,000 to deploy that structure. which is still quite high. We're cost equivalent to other masonry structures right now. So we're not in a place where there's a lot of videos on the internet promising that 3D printing is going to remove 70% of the cost of a building. I think it can probably replace, lower the cost of framing by 70%, but the rest of the building costs have not really been changed yet. Like your MEP, your mechanical, your roof, all of those are still the same, which is why we're starting to look at how we can expand our scope to deliver a higher percentage of the building and start to chip away at those other costs associated with putting up a home. The one in Leamington, I think the total cost for all those 4 units was like $600,000 or something, but it involved 3 years of testing with the university. And it was very hard to break out what costs were actually directly associated with putting up the building and which ones were part of the 3-year research project that went on to get it out of the ground.
Seems like quite a bit. I'm glad I'm in a house, an old house that hopefully will keep me as long as I need. Okay, thank you.
Yeah, we're getting there. It is, maybe not quite in its infancy, but the sector and the technology is definitely at least still a toddler. We're definitely not beyond that. Yeah.
Okay, I'll jump in then. Ian, you mentioned in the video, I guess, that this first project changed the direction of your company. How?
Well,
you picked up an engineer.
We did pick up an engineer, and our build portfolio for the first year of building, we hadn't even planned to start printing until June or July. And Fiona called us, and she had this funding, and they were actually originally working with another 3D printing company that had a small ARM-based printer. And it had become apparent that the printer could not execute the build. It didn't work. And so the 3 years or 2 years leading up to what we did, work with the university, and the funding was actually in danger of being withdrawn from CMHC. And so she called us, and she's like, "Can you think you can do this project?" And it's already been designed. It didn't quite fit in the shape and size of our printer, so we had to figure out how we did what we call print in place lift-in components, where we actually printed some of the walls in the living area and then lifted them and craned them in place after the whole building was done. But she's like, the caveat is you need to start in April or I lose all this funding. And so we had been planning on doing only testing for the first 6 months of operations, and we rapidly pivoted. I called all our print crew on after the conversation with Fiona and said, "Hey, would you basically be willing to go live in a hotel in Windsor for 6 months?" Or it turned out to be less than 6 months, but they were game, and we trucked basically everything in the company down into a temporary site in Windsor and made it work. And I think in terms of the long-term repercussions for the company was the profile that Habitat carries with them, and they were able to help raise the awareness of what we're doing in a way that we could have never done on our own.
And did you get out to BC this winter?
Not to print. We are in BC. We have offices. The plan for BC was probably this coming fall, which I think we're still on track for. So we're right now going back and forth with a group to do 12 home development in the interior of BC, partnering with an Indigenous community to deliver housing.
So we'll ask you again in a year. Well, we're at time now, and Ian, I want to thank you very much for devoting this hour and a quarter to us here. It's been really inspiring. We look forward to watching the developments and just a wonderful example of someone who's taken such interesting turns in his life, and so we wish you the best, and I'm sure paths will cross in a variety of ways between people here and you, and I think it gives us maybe a sharper idea of where we can help to push people on developing policies to make this sort of work more possible, and to help advance the goals that you've that you've set for yourself in your company.
Yeah,
So
thank you.
Thank you again.
Thanks for having me. It was wonderful. I appreciate it. And nice to see some familiar faces and meet some new folks as well.